Um, so I think that it's important to make sure that you are comfortable with the statement. This really explains why interfaces do exist. They exist because interfaces allow collections. Collections is just an example where interfaces are used. But interfaces allow, in our case, collections to be manipulated independently of the details of their representation. Because their representation or implementation is essentially the same thing, right? So how exactly they're represented. Implementation can be, you can write your own list and implement the same interface and create an object and give this interface to a different part of the program, and that part of the program won't know that it's using your code instead of generic collection. It's just it's so simple because once created, your object says, I promise that I fulfill what's in that particular interface. And once you really wrote the code to do that, if you can give this interface to anyone, they can use that interface. So it's very, very convenient. So this is something of really crucial importance in terms of, uh, it's the principle. It's the building block of many designs that people create. Essentially, when designing the software, they will give a lot of attention to concrete classes that fulfill, and implement particular algorithms or tasks. But at the same time, they will say, well, beyond the idea that we have those concrete classes, we'd like to think about what interfaces we should really have, and then essentially manipulate those classes through those well-defined interfaces. And this will be the ongoing topic of discussion in this class, and also like a year from now in CIS 262. I'm sorry, CIS 260, which is the software design class, where we revisit UML, and we revisit Java programming, and really work on a semester-long project using all these principles, and discuss different designs or design patterns that exist, which kind of very useful in studying what the software prepackaged design solutions exist. So much more about this in the future, but this is going to be an ongoing topic of our discussion. Now, naturally, in object-oriented programming languages, interfaces do form a hierarchy. So that, because the form of the hierarchy, such as this one, is really something that compiler knows how to do, is designed to understand the hierarchies, and it will understand that a linked list exists, is implemented and written not just entirely, in its independent and unique form, but it has a connection with the list, and it promises that it will implement everything that list does, or promises everything that the list promises. And so you see this hierarchy. I think it's from the actual user perspective, this is natural to think about, and to try to comprehend. And from the compiler standpoint, this is also a very friendly arrangement when the hierarchy is formed, and hierarchy can be observed and obeyed and verified and so forth. So this really helps to write safer code, and write code that is well organized. So anyway, I am kind of like ready to jump closer to coding examples, but those are some very important topics that I'm trying to say. So very commonly used for each loop with collections, of course, is that you have collection of these objects, and you basically declare a loop like this, and you get access to each individual collection inside to each element inside your collection. Alternatively, there will be a topic of iterators. And it's a little hard to talk about the iterators before we really talked about any specific collection. But uh, I would like to tell you that perhaps we can go to an example that we had before. Here's a more concrete example of this. In this example, what happens is that we create ArrayList. We populate ArrayList with some information right here, and then we create a loop which, as promised, will allow us to print strings inside of this collection of strings. Okay, so I mean it's just like, you know, for each string inside this collection, just give me access to each string. For example, I can print those strings. All right, so this makes sense. The limitation of this construct is that inside the loop, when you eventually get to your elements, those elements, references to these elements, are entirely disconnected from the collection itself. You really don't know where each string lives inside the collection. So what if you wanted to create a loop in which you want to find something and remove that element from the collection? This loop, this for each loop, doesn't allow you to do that. So in case if you want to be able to have your collection examined in a loop, and then inside the loop also be able to remove elements from the collection, in that case you need to use an iterator. So I probably won't go into the details about the iterator. I sort of structured this presentation in such a way that if you print the handout, you know, which follows the same thing, once you start using collections, once you start learning how they work, I kind of prefer to keep this for each loop next to the iterator version of it syntactically. But I won't go into any details right now because we haven't seen any collection. So this I will consider it to be somewhat specialized case, and we will revisit this topic very soon, maybe next week, but definitely before we can discuss the our final project in this class. So certainly this will be the topic that will be discussed. But again, primarily just think about it. If you need to traverse and remove elements, you need something that provides you access to the element and the collection likewise. So that's why we use the iterator. So to demonstrate that, you know, if I may try this, you know, just trying to think how to illustrate it better. So we create a collection, right? So we create a collection like this. And we know that somehow internally there is storage, right? So there are individual storage inside the collection, and these are references to our object. So when we create this collection and we have a reference to this collection, we can use this for each loop, which basically individually will provide access internally to these elements. Inside the loop, we get access to these elements. So we can actually replace them and try to replace them, try to assign new values to them. That's okay. But if we wanted to exclude an element from this collection, it's not enough to have reference to only to the element. We need to be able to access the collection and tell remove this particular element. So that's why what happens is that to the rescue, there are iterators. So what iterator is, an iterator is another object. Okay, an iterator is a helper object which now does both. It contains a reference to the container. It knows where exactly the element lives inside the container. And it also provides you, through the iterator, it provides you access to this element. right? So using the iterator, this helper object, you can get this temporary reference to your element and modify the value, or ask the iterator to say, I want to remove this element from my collection, right? So this is the approach with iterator. So iterators know, so the iterators know uh, how to move around, right? Go to the first element, go to the next element, and so forth. So iterators know how to navigate inside your collections. They can jump to the back of your collection. They can jump to the front of your collection. Iterators know how to do that. But they also can let you get rid of elements, which would be the ultimate, significant manipulation inside of your collection, right? So alternatively, you could write a more complex loop on your own, jump from place to place, and try to emulate what iterator does. But iterators are formalized, that once you learn how iterator works on a list, you can use iterator that works on the queue, on a map, and other things. And it's again, iterator is an interface which, once you learn how it works, you know how to use any collection. So again, iterators existed many times. You don't have to reinvent the same thing. It already is out there for that class of tasks. Just use the iterators, and it's going to solve your problem immediately. So again, but practically, we will revisit the idea of an iterator shortly, definitely very soon.